Hi all, welcome to our channel Techlteworld. Today we'll be discussing about a very interesting topic in 5G-NR, that is bandwidth part, also known in short as BWP. So let us begin. So first of all, let us try to understand why in NR we need bandwidth part. So we have dedicated a separate dedicated slide for it, but here for introduction I just want to start with this actually, so that viewers can understand why this bandwidth part was introduced in 5G. Okay, before understanding what actually this bandwidth part is. Okay, so as we know that in 5G a huge bandwidth is used, right? A huge bandwidth is used. So the problem is that always this huge bandwidth doesn't come in play, right? So sometimes users use case, or depending on the user use case, the use of that bandwidth can vary. Sometimes the user might require a higher bandwidth, sometimes it can require a narrow bandwidth, right? So if our entire bandwidth keeps on active state for the entire period, so it will lead to the wastage of the bandwidth, right? Or it can be used to the wastage of the power consumption for the UE. Okay, so that's the problem. So for this, what is in 5G NR, to increase the energy efficiency for the UE in 5G, this new concept of 5G NR was introduced. Okay, so if you see this its definition. Okay, so you can see that a bandwidth part BWP is a contiguous set of physical resource block. Okay, it's a contiguous set of physical resource block on a given carrier. Okay, so you can think bandwidth path as a set of different PRBs. Okay, where these PRBs are actually formed using a single RB. Okay, using a single resource block, a single common resource block. These PRBs are actually broken into different pieces. For example, if you see a piece of cake, so you can that piece of cake can be divided into several sub pieces, right? And it can be distributed to several other people, right? Similarly, where you can think that the entire bandwidth as a entire cake. Okay, and that small pieces of that cake as the bandwidth part. Okay, like for example, let me show this. Let's say this is that whole cake. You can understand, you can consider this as a entire 5G NR bandwidth. So let's say one has distributed this into this piece. Okay, and someone has distributed into this piece. Okay, and someone has distributed into this piece. Okay, so this will be of certain width, this can be of certain width, and this can be certain width. So each of them, these three can be regarded as the bandwidth part, right? So for example, I just have tried to show you like what from the physical significance, how you can basically take a reference from that, right? So this is the thing. So yeah, so it is mentioned in that definition that these RVs are selected from a contiguous subset of common resource block for a given numerology. Okay, so each bandwidth part is associated with a particular numerology. Okay, and also three different factors are associated with each bandwidth part. One is the subcarrier spacing. So subcarrier spacing can vary, right? Different bandwidth part can have different subcarrier spacing depending on the use case. Okay, so if let's say some user have a requirement of higher bandwidth, okay, so it will have a subcarrier spacing higher means, so its subcarrier spacing might be different as compared to the user whose requirement or use case is requires a narrow bandwidth, so its subcarrier spacing will be different, right? Also the symbol duration will be also different for each bandwidth part. Okay, cyclic prefix length will also be vary. So these three characteristics are there which is associated with a bandwidth part. Okay, so hope you got what is bandwidth part, right? And what is the use of this bandwidth part in the 5G NR. Okay, so if you see this diagram, as I told you in the previous slide, right? So the entire bandwidth part, entire bandwidth of this 5G is can be divided into sub PRBs, right? So let's say you can see that this is the first bandwidth part. Okay, this is the second bandwidth part. Okay, this is the first bandwidth part. Okay, this is the second bandwidth part, and this is the third bandwidth part. So if you see here, the first bandwidth part has a subcarrier spacing of 30 kilohertz, right? And is associated with the numerology mu equal to 1. Okay, and it has certain the FDM symbol will be same only for 14 FDM cell per slot. And let's say consider the bandwidth part 2. Okay, it has a numerology of mu equal to 0, let's say. So if mu equal to 0, what will be the sub-carrier spacing? 15 kilohertz. Okay, so if you don't know about numerology or carrier subspacing, I think we have a video in our channel for 5G-NR frame structure, so you can watch that video and can get a good understanding about this particular terminologies. What is numerology, what is this carrier spacing, how the carrier spacing is getting varied in accordance to the numerology. So you can get that understanding from our video. Okay, so so now again the third bandwidth part is bandwidth part 3. Okay, so bandwidth part 3 has a sub-carrier spacing of 60 kilohertz, and the numerology which is associated is 2. Okay, so in this way we can say that our entire bandwidth part has been divided. So just an example to show you how an entire bandwidth of 5G can be divided to small bandwidth part according to requirement. Okay, so if we see the third slide, so here we are discussing why bandwidth part is required. So in the first slide I just gave one like slight introduction that why in 5G-NR means this bandwidth part was introduced, right? So if we see it, like the use of wide bandwidth part may actually impact the power consumption in both RF as well as baseband signal processing. Okay, so it basically the need of this bandwidth part was to basically reduce the power consumption in the UE side. Okay, so in this regard this bandwidth part was introduced in 5G-NR. Okay, so that to provide a means of operating UE with smaller bandwidth than the configured CBW. CBW means it's configured bandwidth, right? So means the main intention of introducing this bandwidth part was that let's say the user might need a smaller bandwidth, right? According to use case, let's say according to his use case, it might require a lesser bandwidth. So the user should be able to use only that bandwidth which it requires, not the entire bandwidth, right? So if it use for every time, if it uses the entire bandwidth, so it will be of no use, right? So the reliability or the efficiency will be less, right? So and because of this, like the use of 5G-NR will not be you can say no, it will not be justified, right? So that's the thing. So for that this bandwidth part was introduced, so that user can use that bandwidth part only which it requires, not the entire bandwidth, right? So that's the thing. And here it is mentioned that to make the NR as an energy efficient solution despite the wideband operation, means despite making the 5G-NR as wideband operation as just like in the previous generation like LTE or any other previous generation, the main intention of was to make the NR an energy efficient solution. Okay, so this is a very important point. So the main intention was that NR to make an energy efficient solution despite the support of wideband operation. Despite we are using a wideband operation, but we want to make NR as an energy efficient, right? So that's why we have introduced this bandwidth part. Okay, the second thing is that bandwidth part is that UE is not required to transmit or receive outside the configured frequency range, let's say of the active bandwidth part. So there is a concept in bandwidth part, that active bandwidth part, like let's say we have configured 3 bandwidth part in a 5G-NR bandwidth. Okay, for a particular bandwidth, configured bandwidth, we have actually configured 3 bandwidth part. So there's so out of the 3, only at a time only 1 bandwidth part can be active, not that 3 bandwidth part can be. It is made in such a way that only 1 bandwidth part will be active. Okay, so so bandwidth part technology, or you can say the feature is designed in such a way that the bandwidth part that the UE is not required to transmit or receive outside the configured frequency range of that active bandwidth part. So for the active bandwidth part, whatever frequency range has been assigned, so UE has not to receive or transmit outside that particular frequency range, right? So which actually attributes for the power saving thing, right? So there are means what, and here we have mentioned that what are the various areas where this bandwidth part plays a role. Like it basically reduce the baseband processing, right? Requirement to transmit or receive narrow bandwidth, so it basically reduce the baseband processing. So if in case if we are using the entire bandwidth, so the baseband processing would have required a larger larger amount of energy, or you can say it will not be that energy efficient. But with the bandwidth part, that particular bandwidth part, if let's say the user want to use a narrow bandwidth, so for that bandwidth only, particular narrow bandwidth only, the baseband processing will be done, and hence it is a good for the power saving thing, right? And second is bandwidth enables RF baseband interface operation with lower sampling rate. So if and using this bandwidth part, we can achieve the RF baseband operation with a lower sampling rate, and hence if a lower sampling rate is used, it means that it is good for power saving thing, right? And also UE RF bandwidth adaptation can provide UE power saving at least if carrier bandwidth before adaptation is large. Okay, this is also one of the use thing, right? So if we go in this, so I hope you got right why bandwidth part is used. So this is very important to understand that the main intention of 5G NR bandwidth part is to make the NR an energy efficient solution despite using a higher bandwidth. Okay, now let us discuss about various configuration properties of bandwidth part. Okay, so the first configuration property, if you see, is very important one, that UE can configure up to maximum of 4 bandwidth part, okay, for downlink and uplink, but at a given point of time, only one bandwidth part is active for downlink and for uplink. So for downlink and uplink, only one bandwidth part will be active, and a maximum of 4 bandwidth part can be configured for that particular UE. Okay. Second is bandwidth part concept enables UE to operate in lower bandwidth when the user demands more data, right? Like bursty traffic, or it can inform a GNB to enable wider bandwidth, right? So means according to the UE requirement, according to the user requirement, and according to the use case, let's say if UE wants that a narrow bandwidth is required, so it can configure the bandwidth part according to that. And let's say if user demands a higher bandwidth, so it can configure a wider bandwidth. So it is quite flexible and user friendly, right? So that's what a bandwidth part is serving, right? The purpose of user friendly, like according to user requirement, it will change its nature, right? When GNB configure bandwidth part, it includes parameters like, as I discussed, bandwidth part numerology, bandwidth size, frequency, location, that is NR, ARFCN, and as well as core set. So core set, don't worry, like we'll have a separate video for this, but just for now, you just I just want to tell that core set is nothing but it's a control resource set in 5G NR. So it is also a new feature introduced in 5G, just like bandwidth part. So here what happens that we instead of dedicating an entire means covering the entire resource block with resource block with the controls, with the physical resource, we are basically dedicating a small section in the resource block, okay, in the control channel, you can say, for this particular for the RBs, right? So this is the concept of core set. Okay, for now just understand that what is core set. We'll have a separate discussion in separate video. Okay, so this is one thing. And with respect to downlink, UE is not expected to receive PDSCH or PDCCH or CSIRS or TRS outside an active bandwidth part. So UE, these all are downlink messages, messages, right? PDSCH, PDCCH, or this is the physical information like CSIRS or TRS. So with this bandwidth part, UE is not expected to receive all this information outside the active bandwidth part. Okay, anything outside the active bandwidth, it will not receive. You will not receive it, right? Each downlink bandwidth part include at least one core set with UE specific space, while primary carrier at least one of the configured downlink bandwidth includes one core set with common search space. Okay, so so it is told that like each downlink bandwidth part can include at least one core set, okay, with UE specific search space. Okay, so each downlink path can configure one core set. Okay, that's the thing. And with respect to uplink, UE shall not transmit any PUSCH or PUCH outside active bandwidth. Similarly to receiving thing, like it can receive anything outside the active bandwidth part. Similarly to that, UE shall not transmit any PUSCH or PUCCH, that is the uplink information, outside the active bandwidth part. Okay, and UE are expected to transmit and receive only within the certain frequency range configured for the active bandwidth part with some associated numerology. Okay, however, there can be some exception that the UE may perform radio resource management or transmit some SRS signals, right, outside the active bandwidth part. So there can be some exception, but usually UE is expected to receive and transmit only with the certain frequency range only. Okay, so the last thing is the concept of activation and deactivation. Okay, so as I told that means that there exists a concept of active bandwidth part, right? That and also I told that out of all the configured bandwidth part, at once only one bandwidth part can be active. So there it means that we can activate a particular bandwidth and also we can deactivate it. It means that we can switch on or switch off, right? Just like what we do in our home appliances, right? We can switch on or switch off. Similarly, there is also like a configurable thing that we can switch off or switch on the bandwidth part. Okay, so and there are different ways to do it. So here we have discussed certain methods by which we can achieve it. First, the dedicated RSC signaling. So this is one of the way, or we can make use of downlink control information DCI, or there is a very good method called bandwidth inactivity timer. Okay, so so this is one of the timer which can be used, right, for the switching on or switching off of bandwidth part. And fourth one is MAC control element. Okay, so this DCI based mechanism, okay, this DCI based mechanism which I mentioned in the second point, okay, although it is more prompt, or means you can say more better than the MAC-C, okay, MAC-C method. Okay, but sometimes it requires additional consideration for error case handling. What does the error case handling means? By the error case we mean that sometimes UE might fail to decode the DCI, okay, containing the bandwidth part activation or deactivation command. Sometimes what happens that UE might fails to receive DCI commands, right? For that case, you can say, means it's just like that DCI loss scenario. You can consider that sometimes UE might fail to decode the DCI, okay, or it might fail to receive the DCI. Okay, in that case, the activation and deactivation of downlink bandwidth part, okay, by the means of we can achieve, means it means that sometimes this DCI method can be inefficient, right? So we can make use of this bandwidth inactivity timer in that case, right? So by the use of this bandwidth inactivity timer, means UE will be UE is not scheduled for a certain point. Means by using this we can let UE to not be active for that particular time. Okay, so if it's not active, then it means that it will not transmit, and hence there will not be loss of this DCI. Okay, so we can configure the inactivity of that particular UE, okay, in this way. So this is also one of the method which is introduced in 5G-NR bandwidth part, this bandwidth inactivity timer. Okay, so this is one thing you can like consider, right? And one thing is more, that there is an initial active bandwidth path for a UE during the initial access until the UE is explicitly configured with the bandwidth part during or after RSC establishment. So there is a concept of initial active bandwidth part. Okay, so initial active bandwidth part, what does it mean by it? That means there will be a default, you can say a kind of default active bandwidth part which will be active once the RRC connection once an RRC connection establishment is done. Okay, so once the RRC connection has been established, there will be a initial active bandwidth part or a default bandwidth part which will be configured for the for a UE. Okay, and later if the requirement changes, okay, then it can change to different bandwidth part, that is fine. But an initial active bandwidth part or a default bandwidth part will be configured always after the RRC connection establishment. Okay, and let's say like as I gave an example of this bandwidth inactivity timer. Okay, so when this during this bandwidth inactivity timer, when it is on, okay, so UE will let's say UE was connected to some particular bandwidth part. Okay, and now once this bandwidth inactivity timer is on, so for that particular bandwidth part with which this particular UE was configured, so that it will lose its that bandwidth part will be inactive, and then UE will basically move to this default, or you can say the initial active bandwidth part. Okay, it means that always there will not be any case, okay, there will not be any case where no bandwidth part is configured. Okay, so let's say if all the bandwidth part all the working bandwidth part got deactive, then this initial active or default bandwidth part will be come in play. Okay, so that's the thing. So this is very important point, that always no matter what, if let's say all other bandwidth part which was configured later got switch off, or you can say got deactivated, then this initial active or default bandwidth part will always come in play, which got configured after the RRC connection establishment. Okay. And as per 3GPP release 15, for a UE, there should be at most one active downlink bandwidth part or one active UL bandwidth part. So according to the release 15, there should be at least one downlink bandwidth part and at most one active UL bandwidth part. Okay. Hard transmission across different bandwidth part is supported when a UE active bandwidth part is switched, and also this hard transmission across different bandwidth part is only supported when at least one UE active bandwidth part is switched. Okay. Otherwise, hard transmission, retransmission will not be supported. Okay. So that was our video on bandwidth part. Hope you like it. Please subscribe to our channel so that you can basically access more such videos and get a good insight about various topics of on LTE and 5G. So keep supporting us, guys. See you in next video. Thank you.